Moshi moshi. Now, I want to ask you something. We're going to continue with the eliminating parameter for reals now, because we finished on part 1, the eliminating parameter, which was so cool. Now, I have a question for you. Do you know what this graph is? Okay? But I just showed you a magic trick, right? If we eliminate the parameter, perhaps we can convert it to a rectangular equation, which involves x's and y's only, which is what we're used to, right? So you may be able to tell what kind of graph this is. So we're going to see if we can do that. Now, we're going to do this one without even graphing it first using parametric equations. Oh, sorry, my heart is leaning back. So I'm going to fix my heart. Bless my heart, okay? Oh, sorry, I had to go there. Let's actually first eliminate the parameter and see if we can tell what this graph is. And then we'll match it if we use parametric equations to actually graph, okay? So let's try this. So we have here x equals 1 minus t, 2t, and y equals 2 minus t. Okay, and it looks like it continues on forever from indefinitely, negative infinity to infinity, okay? So I know that x is 1 minus 2t. And here's the thing. You could choose whatever is easier for you. And I think you have an idea of what you're going to do. We're probably going to use substitution, you're probably thinking, right? Should we set y or should we set t equal to in terms of y? Whatever you want, okay? Okay, so I'm going to just use the x because it's the first equation given, okay? Now let's solve for t. That means t must be, well, I'll just make it easy for us. 2t, okay, is equal to 1 minus x. Are you there yet? And then t is eventually equal 1 minus x over 2. Okay. You're like thinking, why don't you use y and solve for t? But I mean, it really doesn't matter, okay? You can do whatever is easier for you. So you know that for sure that t is 1 minus x over 2. Okay, that means every time you see a t, you're not going to plug in a t, you're going to plug in whatever it is in terms of x. So now let's go here. Y is equals 2 minus t. This t now could be replaced using a y, x. 1 minus x over 2. Well, whoa. Already? Isn't this a rectangular equation? What makes it a rectangular equation? There's no other parameters besides x and y. Anytime it says x and y, you're all in good shape, you're in really good shape. So let's simplify this ugly looking guy. Okay, so I'm going to go y is equal to 2. Let me just factor out the half here. So you know what? Let's actually take out the half and we get this, right? And we get y is equal to 2 minus half plus 1 over 2x. So when we simplify that, we actually end up with 1 over half x. So half x, whoa, plus 3 over 2. Whoa. Now let me ask you the same question. Can you identify this curve? Can you identify this curve? It is. Wait, let's actually write some couple of things. This is rectangular. Because, and you could finish this sentence. Oh, whoa, my pencil's acting crazy. It's because my box moved, okay? Oh, sorry, guys. Whoa, that was scary. Oh, shoot. Let me get this back. How entertaining is that to watch, okay? Anyways, let's erase all this nonsense, okay? So why is it rectangular? You're going to finish that sentence for me. This is rectangular because. Rectangular, we know because. Finish that. Fill in the blank. It should be because there's only x's and y's, okay? Now, what kind of curve is this? It's a line. It's a linear. Oh my gosh. Wait, could you tell by looking at these two parametric equations that it was a line? No, but now you could. Uh-oh. Now if I ask you to graph, what can you graph? You know that you can graph this guy as 3 over 2. Like you remember when you were a baby? 3 over 2. Up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. Down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. You know, you do your thing, right? Okay? And then you're like, oh, I can actually graph this guy. Oh my gosh, this is this graph. It's a straight line. But it's not just a straight line. You forgot what? Orientation. It's a parametric equation, so we need orientation. What does that mean? We need to know which direction this graph is going. You know, when we used to just graph this using y equals mx plus b, we would just graph this like this, and we would say, oh, it goes on forever, because it says that t goes on forever and ever. However, this is a parametric equation, therefore we need orientation. That's what makes this guy extra special. And we're going to find, well, in order for you to do that, why don't you just plug in a couple of points? Let's go like this. So what I'm going to do at the bottom, okay, I'm going to cover it up a little bit. You don't have to try all of them, but let's just do our typical table, okay? T, X, Y. And let's just go from -3. Let's plug in these values here, and let's see what we get. I've already done all the math for you, so we get 7, 5. We get 5, 4. Just plug it in. Just plug it in. T goes in here, and T goes in also here, and you get the X and Y values. 5, 4. I also got 3, 3. 0, I got 1, 2. 1, I got -1, 1. I'm just plugging it in, chicos. Not too difficult, okay? Now, this is going to show you the direction this graph is traveling. How? Let's look at it, okay? -3. When T is -3, it's 7, 5. 7, 5 is 1, 2, 3, 4, 5, 6, 7, and then 5. Now, this guy occurs when T equals -3. Okay? Now, -2. -2 happens 5, 4. 1, 2, 3, 4, 5, 4. That's T equals -2. Oh, I think you're already getting the idea. But just in case, let's check another one. Let's just check random one. 0. 0 is 1, 2. 0, 1, 2. That's when it's 0. Let's try 3. Let's try last one. -5, -1, 2, 3, 4, 5, and 1. Oh, that's when T equals 3. So you see this graph is traveling this way. So do you see what the power of parameters is, that it shows orientation, okay? So before you didn't know orientation, but now we have more information about this particular situation and in the way that it's traveling. So we could have predicted that it was traveling this way, but actually, in fact, we're not. Because that's the direction that we graphed, right? But actually, it's going this way. So that's going to be the fun part of parametric equations, okay? So now, do you see the power of eliminating the parameter? You should be able to see the power of that. And do you see the power of the orientation? Those are the two kind of things that are really cool about parametric equations. Now, so that was fun. Now, how about you try this one here? You're right. It's very, very similar to the one that we did before on part 1. Go ahead and first eliminate the parameter. Go ahead and eliminate the parameter. You can use X or Y to solve for T if you want to, or use a little trick. If you want to go back to example from part 1 and try it, try that too. Stop the video if you want to, but you can also follow along with me. All right, this one looks a little bit tricky-dicky. I don't know what this graph looks like, but maybe you do. Okay, hinty, because I kind of gave you a hint last time, right? First step. Let's start writing a lot of things. You know for sure a couple of things. Like, you know that there's an X and a Y, and we need X's and Y's, okay? So X squared plus Y squared, you know it's 1. We learned that before. You know where we learned it? We learned it last unit, right? You remember the Pythagorean identity? That's the most important one. Maybe I'm jumping the gun. So let's actually not write that, okay? You know that in this case, our X is this guy. I don't want to jump the gun, okay? So it's going to be X is 2 cos t squared, and your Y is 2 sine t squared. So what does that mean? That means our X squared plus Y squared is equal to 4 cosine squared t plus 4 sine squared t. Do you follow? Amigos, do you follow? Yes, okay. Now, I'm going to go X squared plus Y squared. I still see t's. I don't want to see any t's, remember? I have to eliminate the parameter, okay? So I'm going to factor out the 4. I'm going to go cosine squared t plus 4, sine squared t. Sine squared t. Ding, 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 ding. Pythagorean identity. Like what I mentioned earlier, I was kind of giving away. I was giving TMI earlier. So wait, so that means X squared plus Y squared is equal to 4 only because this becomes 1. Wait, why did it all get ugly like that, okay? She goes, isn't this guy just 1? Yeah, that's just 1. That's the Pythagorean identity. So your equation is this. That is, you have just now eliminated the parameter. This is a rectangular equation, which means it only involves x's and y's. So wait, what is that? Isn't that a circle at the origin of 0, 0 with a radius? Wait, circle? Origin 0, 0 with the radius of 2? Oh my gosh, so you mean I can just graph this graph like this and just make a circle. Of course, I don't know the orientation. This is a really ugly circle. Okay, solved. Okay, this is an ugly circle, but it's not bad. Okay, you get the idea that it's a circle, right? Okay, it's a circle. Okay, it's a circle. Now wait, it's a circle, but we don't know the orientation. So just try a couple of coordinates. Okay, try a couple of coordinates from 0 to 2 pi. At 0, it's t equals 0 at 0, right? Just plug it into each of these equations, okay? But you can't always trust yourself, but most of the time it is true. Let's try a cosine of pi over 2 is 1 times 2 is, so that must be here. Pi over 2 and so forth. So you already know that the orientation is going to go this way. I'm going to expect arrows, and I'm going to actually expect for you to actually label your orientation or your t values, okay? Like this. Oh my god, it's a circle! Okay? All right, so that was kind of cool. And so we've eliminated the parameter, and we saw the power of what is important about eliminating the parameter and what it does for us, okay? I'm going to just write a couple of things to remember as you do these problems, okay? Useful. I'm sure you could kind of guess what the useful hints are. Okay? Here are some things. Sine squared theta plus cosine squared theta, which we dealt with a lot of last unit. That's really important. X squared plus y squared equals r squared. Or, if you have a origin that's at a different position, then you have to remember this circular formula. Okay? Also, do you guys know this? Parabola. This is a parabola. Did you know that? Well, you know that this, you know that this is a parabola, right? This guy here, that's a parabola. But you know, I want you to also remember that this guy goes this way or this way, okay? But you know, what if you had this? What if you had that? Can you think about which direction that this is also kind of a parabola. If you plug in points, you can probably figure that out. But just know that this one is a horizontal parabola that goes this way and this way. Okay? Okay, so let's see where that comes into use later, okay? Thank you for watching. Watch the next video. Bye!